Hello, I'm John Ferris, and this is my video reflection journal number 4. In this journal, I will demonstrate two statistical analyses using SPSS, namely the independent samples t-test and the paired samples t-test. The purpose of this VRJ is not only to run the analyses that we are required to for our assignments, but also to demonstrate conceptual understanding by explaining why each test is appropriate, how these assumptions are checked, and how the results are interpreted in context. I will first demonstrate the independent samples t-test, followed by the paired samples t-test. Now for the first computation, which is going to be the independent samples t-test, my research question is there a significant difference in the math test scores between ELL classified middle school students and non-ELL classified middle school students at the school district? The key verb in this research question structure is difference between. According to the verb analysis framework, the phrase difference between the two groups signals that there are the only appropriate statistical test to be done, and that is the independent samples t-test. In this analysis, we will be dealing with two types of variables, both an independent variable and a dependent variable. The independent variable will be the ELL classification, and this type will be categorical or nominal, and that will consist mostly of the ELL students, namely those that are ELL and those who are non-ELL. And then we'll have the dependent variable, which is the math test score. And this score will basically be a continuous or interval ratio scale type of score. The independent samples t-test is appropriate to use in this particular computation because we are comparing the mean scores between two independent groups on a continuous outcome. Now I will state the hypotheses, and there are two, basically the null hypothesis, of course, and the alternative hypothesis. The null hypothesis states, of course, that there is no difference between the group means. In other words, there is no statistically significant difference in the math scores between ELL and non-ELL students. Symbolically, this will be measured at H sub O is going to be measured as mu one sub 1 equals mu sub 2, and they're both equal, meaning there is no difference between the two. The alternative hypothesis for the H sub 1 states that there is a difference between the means of those scores. In other words, there is a statistically significant difference in the math scores between ELL and non-ELL students. And that'll be measured at H sub 1, mu 1, and mu sub 1, or rather mu sub 1 and mu sub 2 are not equal. This is a two-tailed test because the research question does not predict which group will have higher scores. We set the alpha level for this analysis at 0.05. Now we use 0.05 because this is an alpha level representing a 5% risk of committing a type 1 error, meaning incorrectly rejecting the null hypothesis when it is actually true. The 0.05 level is widely accepted in social science research because it balances statistical rigor with practical feasibility. We also have to be careful to check our assumptions. Before running the independent samples t-test, several assumptions definitely must be verified. Number one, the continuous dependent variable, and that would be the math score is measured numerically on a continuous scale. So this assumption is met. Also the independent group, which would be the ELL. And if we scroll down further, we've measured that in the assumptions check noted here. That would be the ELL group. They do not appear in both groups, therefore the observations are independent. Okay, now we need to check normality. And that is whether the dependent variable is normally distributed within each group. To do that, I need to stop sharing really quick and go into the worksheet itself to walk through the process of how we're going to make that computation. Okay. To do that, we will go to our, now we are sharing screen. Hopefully you can see my screen and you'll be able to see the K-12 worksheet. We will go in SPSS to analyze. If it's going to cooperate with me today. analyze descriptive statistics, and we'll go to another pull down menu, explore. Okay, when we get there, thankfully we have already set this up ahead of time so that we have the math score is going to be put in the dependent list, as is indicated here. The ELL stat is going to be in the factor list, and we indicate that there. We've already gone into our plots to make sure we're going to provide for histogram and factors level together and normality plots within those tests. Okay, selecting continue, and we click OK. We have already made this computation, so again, I will stop sharing again, and we'll take a look at the results page as shown in the share screen here, and that's our output share, and we can see the computative results here. The QQ plot score for both of those is measured, as well as the histogram has been measured, and so on. The final assumption, of course, is homogeneity of variance, meaning that both groups should have similar variance. This will be tested with the Levine's test, which appears the SPSS output when the independent sample t-test is run. Now, we have already run that already. To do that, we're going to go back and share my screen once again to walk through the process of how we do that. And we share screen once again. Again, we'll walk through need to do to computate that. That will be going to analyze once again to compare means and proportions, going to the independent samples t-test. We've got the math score, K is the test variable. The ELL will be the grouping variable. ELL status, students that are ELL status will be 1, and those that are non-EL status will be 0. And we're going to computate and estimate effect sizes as well. So let's go ahead, and that we'll stop sharing. Go back to the computation page that has already been provided for us. And there we'll click share. And at the bottom of the screen will be our independent samples t-test, which has already been computed. And there's our t-test. We have the t-score listed, the DF, the significances listed, as well as the mean and standard deviation. And next, I'll compare the p-value to the t-test at the alpha level 0.05. If a p is less than 0.05, I reject the null hypothesis. Or p is greater than 0.05, if p is greater than 0.05, I'll reject the null hypothesis. If it is less than 0.05, I'll fail to reject the null hypothesis. I also report the effect size using Cohen's d. And if we go to Cohen's d, that's going to be listed right here, a positive, but 0.019. Okay. Obviously, that's going to be a lot lower than 0.05, indicating a negligible, no effect. And at that point, we failed to reject the null hypothesis, indicating that there is no practical difference between these two groups. I will stop sharing here, and that's to show you that the computation was made. I did make the computation through there. We'll go and share the screen again as I recorded in the summary sheet. Let's go ahead and share back where we're at. Again, I apologize for any sort of delay there in between. There it is. Okay. There's where it's recorded. We went to the computation, and the independent test was made, and the value was at 0.019. In the case, these findings indicate there is no statistical significance between the two groups. The effect size at 0.019 is far below the threshold of no effect, and practical difference is non-existent. And In terms of reflection, the difficulty I found was fully understand the effect size does help turn practical significance, not just statistical difference. And if the test had been statistically significant, it would have indicated a meaningful difference existed between classified ELL middle school students and non-ELL classified students. Okay, I'll go ahead and stop sharing at this point, and then we'll go on to the paired samples t-test. We'll refer to our sheet once again. We'll go ahead and share our screen. We'll go to our paired sample so you can see how I was making that computation. Let's go ahead and share that screen. And we'll scroll back up to the top, and we'll go ahead and read the research question for this also. Namely, is there a significant difference in reading scores between the ELL students and the non-ELL students participating in the literacy intervention program? The verb identified for it is the difference between ELL and non-ELL students. That would be a comparative venture, of course, and we've marked it there as a verb comparative. The independent variable is going to be the language level, ELL students versus non-ELL students. It will be an interval and ratio reading on the reading score. And this is appropriate because the same participants are measured twice. Now we will state both the null hypothesis and the research and or the alternative hypothesis. In other words, there is no statistically significant difference between the ELL and non-ELL student reading scores, and that's indicated there in the symbols listed below. And there is the alternative hypothesis or research hypothesis H sub 1 is that there is a statistically significant difference between the ELL and non-ELL student reading scores. And the symbol H1D is not equal to 0. The alpha level remains at 0.05. This level controls the probability of incorrectly rejecting the null hypothesis. So let's go ahead, and we also need to check the normality of those scores as well. We will go to the stop share, and let's go back to our K-12 sheet to make the computation again. Shall we walk through it? To make those computations, we will go to course analyze. Go to descriptive statistics and go to explore. And we have the math score and the ELL, EL and non-EL students. So instead of the math score, we're going to have the difference of those scores, and that would be the reading scores. We're going to move that one out and put in, computate the reading score and put that in there. And then we will run the paired samples t-test through there. And we'll go ahead and that out. And then we'll demonstrate that to run the paired sample t-test, obviously we're going to go to analyze. And then we're going to go to compare means and proportions and be the paired samples t-test. And make sure that we include the reading score, of course. And variable 2 is going to be the ELL status. And then once we make that computation along with the intervention, we will click OK. Okay, we've already run that computation. I'm going to stop sharing here at this point, and then we're going to go to share once again. And go to our station result. And this will be these are the results that I gathered from the paired t-text, paired samples t-test. And the mean and standard deviation was negative 91.182, And reading score, pair 2 was 0.91.201. And computations and the effect sizes, and Cohen's D that, so we'll go ahead and stop sharing at this point, and then we'll go to the results which I dated and gathered from the paired sheet status. And as the APA results statement records, the paired sample t-test was conducted to compare reading scores between ELL and non-ELL students in the intervention program. There was a significant increase in reading scores from ELL students. The mean was at 0.20. Steve was 0.399 to non-ELL students at mean of 30 and standard deviation 0.457. T at 671.3 was greater than 0.05, and the D was at 3,600. These findings indicate that there is substantial significant difference between two groups. Effect size is incredibly high effect, and the intervention produced tremendous improvement in the reading scores. And that value was recorded. Now let's go ahead and make sure we down, and it was 8 standard deviations actually, if you want that, and I'll write that and record that as well. Was at 0.151, and 8.07. So if we go to that computation and go that reading, it was within 8 standard deviations, which indicated a high result score. So let's go ahead and go back to our summary sheet for the results, and I will record that there to make sure. Because this test was statistically significant, improvement was roughly 8 standard deviation from the effect size, surely reveals a meaningful difference between classified ELL middle school students and non-ELL students in their literacy intervention participation, and magnitude of that difference has real-world educational implications such as pinpointing achievement increments and enhanced instructional strategies. Any challenges or barriers for the future was showing the test was statistically significant for myself, and the difficult understanding of the test result is statistically significant. It indicates that literacy intervention induction produced a meaningful change in those reading scores, and that is important at the K-12 level because they are always seeking improvement for those students and are constantly measuring that increment at the elementary and middle school levels as well as the high school levels. So they are statistically significantly important to administrators and teachers and the like. This concludes my presentation. If you have any questions, please let me know. Hopefully you're able to share screens. We're a lot better this time, and they provide a better flow in terms of interpretation and gathering and recording. Thank you very much for your attention, and have a wonderful day.